In this screencast, I will demonstrate how to integrate FASTEN models into continuous integration pipelines on GitHub. To demonstrate this, I have created a GitHub repository, which can be forked and used as starting point for the integration of other FASTEN projects in CI pipelines. I have cloned this GitHub repository locally on my hard disk. For enabling the integration of FASTEN models in pipelines, our repository contains, besides a FASTEN project, also an integration with the build system Gradle. We create a Gradle script to download a specific version of FASTEN, start the tool, and execute commands such as generating code from FASTEN models, or running the checks in headless mode from command line, without starting the graphical user interface. The Gradle script for triggering all these actions is written in Kotlin and is named build.gradle.kts. For downloading FASTEN, Gradle needs to access the GitHub Packages repository. For this, you need to create a file, gradle.properties, by copying and renaming the file gradle.properties.example, and set inside your GitHub username and token with access rights to GitHub Packages. The steps needed to run the scripts are described in the readme.md file inside the root directory of the FASTEN_demo repository. In FASTEN_demo directory, we have start fasten.bat, which can be executed to start the tool. This command uses Gradle to download the tool in the build directory. After FASTEN is downloaded and unpacked, start fasten.bat simply starts the tool. The exact version of the tool, together with eventual other dependencies needed by our project, is specified in the gradle.lock file, which is part of the Git repository. This ensures for any given commit reproducible builds on different computers and on the CI server. The lock files allow us to go back in time at arbitrary commits and reproduce the state of the system at that point in time. This is especially relevant when we have different release branches on which patches must be implemented. All needed artifacts configured as dependencies in Gradle are downloaded in the build directory. This directory is initially empty. Let us start now FASTEN by running start fasten.bat. When the batch file is executed, we notice a step called resolve FASTEN. In this step, the Gradle build system downloads and unpacks the tool into the build directory. If after a few seconds we look in the build directory, we notice that a subdirectory FASTEN is created. This subdirectory contains the tool. As presented in previous screencasts, FASTEN ships a large amount of consistency checks. They can be triggered on the entire project, on a single solution, or a model by performing a right-click and selecting Check Project, Check Solution, or Check Model. Whenever the model checker finds errors or warnings, they are displayed in the results window, and by double-clicking on the entries, we can navigate to the model parts which cause these errors or warnings. When the predefined checks are not enough, or when we need special cases, FASTEN also allows the users to define various kinds of custom consistency checks. These custom checks are defined as code snippets using Java and extensions provided by the platform, which allow access to models. An example of a custom check is that each of the legs of the top-level goal of a safety case have specified a responsible. When we open the structured assurance model, we notice that indeed, all goals immediately below the top goal have associated with them a responsible. The responsible is modeled as an attribute in the inspector window. If we delete a responsible attribute and run the model checker again on the model containing the custom check definition, the custom check will identify an error, the missing responsible. We fix the model by reverting the change. All these checks can be ran every time locally in the IDE when we want to check the consistency of models. The same checks can be, however, executed also as part of a continuous integration pipeline. To generate the scripts containing custom logic and running the model checker, we use the command Gradle. I am demonstrating the running of these commands in a local terminal. We start with Gradle and redirect the logs into a file to keep the output clean. The first task called by Gradle is to generate the code for the custom checks. For this, FASTEN is started in headless mode, and the generator is triggered on the models containing the custom scripts. The second task is called by Gradle is to run the checks. Again, FASTEN is started, the project is loaded, and the checks are run. Running this command takes a few minutes since it unpacks the FASTEN tool, starts it, opens the project, and performs the generation and the model checking. These checks can be also executed as part of a workflow specification, which is saved as a YAML file in the .github directory of the project, inside the Workflows subdirectory. This workflow is triggered when commits are pushed on specific branches, or when a pull request is opened, or when the workflow is triggered manually. The YAML file contains the specification of the workflow steps. In the check model step, we simply call Gradle, as we did locally. For this demo, I am creating a branch. Perform a small change by adding a new top-level subgoal. This new subgoal does not have assigned any responsible, and thereby it violates our custom consistency check. And accidentally removing the root node, _020_UAV_operating_spec, which causes a broken reference. These changes violate both default checks, broken references, and a defined custom check, which require that all goals below the top-level goal should have associated a responsible. If we run a check on the entire project in the IDE, we find these errors. These errors are identified also on the CI. Let us briefly review the changes. We added a new subgoal and deleted a root node containing an ODD specification. I am committing the changes on the newly created branch and push them to GitHub and open a pull request. After the push is completed, we immediately see the newly created branch in the GitHub interface. We open a pull request, give a meaningful title and description. Once the PR is open, the workflow is immediately triggered and checks are ran on the server. After a few minutes, the checks are completed and we see the induced failures. The same error message as in the FASTEN IDE is displayed in the log of the CI workflow run. Each error has associated a link. If we click on this link, the node corresponding to the error is opened in the IDE. The repository can be configured to prevent merging pull requests as long as checks are failing. Thereby, we can ensure that on the main branch, we push only consistent models. The actions performed in the IDE, such as performing consistency checks on the models or generating various artifacts, can be performed on the continuous integration server as well. To sum up, in this screencast, we demonstrated how to integrate FASTEN models in a CI pipeline by using the build tool Gradle and GitHub workflows. In a similar manner, like building software factories for software development, We integrate FASTEN into automated workflows of a safety factory. By having the configuration of the tool and other dependencies saved into lock files in the repository, we can achieve reproducible builds. The same error messages as in the IDE are also displayed on the CI, and they are linked with corresponding model elements from which these errors originate, and this facilitates understanding the error. Having the possibility to run the checks continuously as part of the CI and the integration with GitHub enforces various quality gates and process steps as precondition for merging working branches into the mainline. This, in turn, ensures that the mainline contains only consistent models. All these pull requests are saved in the history of the GitHub project, and thereby a high transparency about who implemented a change, who reviewed it, what checks were ran, and thereby a high degree of auditability can be achieved. Give this a try in your own workflow and see how it fits. Thank you for watching, and see you in the next screencast.